Hey, welcome to another video. This time I'm going to be solving a spring mass system problem, and this does require some sort of memorization. I've memorized some of the basic forms of the equations, so if you're struggling with these problems, I would recommend at least memorizing the basic forms of the differential equations, and everything that you've learned up until this point in your differential equations class builds up to this. So if you've been at least trying to memorize stuff up to this point, or you've been trying to improve on your math skills by doing extra practice problems and spending time actually, thinking about the material in a way that you spend extra time doing it, doing extra practice problems. Doing extra practice problems is the best way to get better at math. Doing extra practice problems is the best way to solidify things into your memory. So if you're doing extra practice problems, then this stuff is more likely to stick with you. So everything that you've learned up until this point is actually making this type of problem quite easy, because it's the same thing that you've been doing up until this point. So the problems, the word problems, are not actually that difficult. They're just building on what you've learned up until this point, and then now they're giving you a real world application that you can look at it and put it into a general equation that we've learned up until this point, and then use every method that we've learned so far to solve it. And when I say every method, I mean not every single possible one, but it's either a complementary function that you're going to be solving using an auxiliary equation, a particular solution that you're going to solve using undetermined coefficients or variation of parameters, and then use superposition to combine the complementary function and the particular solution into one general solution. And that's pretty much all it is. So if you know how to do those things, then these linear model problems using spring and mass systems are no different than those. So this is going to be quite a long video. Maybe, I don't know how long it'll be, but find out after I finish recording this. But this is the problem. A mass weighing 16 pounds stretches a spring 8 8/3 of a foot. The mass is initially released from rest from a point 2 feet below the equilibrium position, and the subsequent motion takes place in a medium that offers a damping force numerically equal to 1/2 times the instantaneous velocity. The goal is to find the equation of motion if the mass is driven by an external force equal to f of t equals 10 cosine of 3t. So let's begin by writing down what we're given. A mass weighing 16 pounds stretches a spring 8/3 of a foot. So the force is equal to 16 pounds. The mass is equal to weight divided by gravity. Gravity in this equation is going to be 32 feet per second squared, because it's in the engineering units. And I'm not too familiar with engineering units. I know the book talks about it a little bit. So whenever you divide weight by gravity, you're going to have feet divided by feet per second squared, which ends up being seconds squared, which is slugs. I've never used that unit ever outside of math, so I'm not quite sure the interpretation of it in terms of inches and meters and feet and grams, but the unit is slugs. So weight divided by gravity is 16 divided by 32, which is 1/2 slugs. Then S, the distance stretched by the mass, is 8/3 feet. Next, we have the damping force. In my book, I use beta. I know beta is also used in the complex conjugates form of some general solutions, and therefore it's used 2 different times for 2 different uses. But because I learned it that way, I'm going to use it that way and mentally keep track of which beta is which. So the damping coefficient beta is equal to 1/2. Now the initial conditions that are given are x of 0 equals positive or negative. In the spring mass problems, the distance below the equilibrium position is positive, and the distance above the equilibrium position is negative. So when we have 2 feet below the equilibrium position, that means x of 0 is positive 2. Then the masses initially released from rest means x prime of 0 equals 0. Now that we have all of the given factors written out, I will write the general solution, the general equation that we're going to be working with from this point on. The general, the general equation that is for the spring and mass problems is this: mass times the second derivative of x with respect to time plus the damping coefficient times the first derivative of x plus the spring constant times x equals 0 if there's no driving force. That would be a homogeneous equation, but this is a non-homogeneous equation, a second order linear non-homogeneous differential equation, second order non-homogeneous linear differential equation. So it's going to be equal to a function g of x. That function g of x is f of t, which is 10 cosine of 3t. So that's the form of the equation that we're going to be working with. So let's just plug everything in. The mass is equal to 1/2 x double prime of t. The damping coefficient is equal to 1/2 x prime of t. The spring constant k is equal to force divided by the stretch s. F over s is going to be equal to 16 divided by 8 over 3, which is 16 times 3 divided by 8, or 2 times 3, which is 6. X equals 10 cosine of 3t. So now we can do exactly what we've done with other problems up until this point. First, we solve for the complementary function by setting the left-hand side equal to 0 and solving the auxiliary equation. And then after we find that, then we solve for the particular solution using either variation of parameters or undetermined coefficients, whichever one you think is easier. So let's denote part A is going to be the auxiliary equation, x sub c. The auxiliary equation is going to be 1/2 m squared plus 1/2 m plus 6 equals 0. Now let's multiply through by 2 to make it easier to work with. M squared plus m plus 12 equals 0. Now we can solve this using the quadratic formula or the Post-and-Low method. I prefer the Post-and-Low method because it's easier to use. The Post-and-Low method says negative b divided by 2 minus u times negative b divided by 2 plus u equals c. B in this case is 1, so negative 1 over 2 minus u times negative 1 over 2 plus u equals 12. Solve this for u, so we have 1/4 minus u squared equals 12, and then negative u squared equals 48 over 4 minus 1 over 4 is 47 over 4. Divide by negative 1, take the square root, So we have u equals the square root of 47 divided by 2i. Now we plug this u back into these two factors. So we have the first root, m1, is negative 1/2 minus the square root of 47 over 2i. The second root is negative 1/2 plus the square root of 47 over 2i. Now this is the part where the beta is used twice, because whenever you learn about the auxiliary equation and then plugging it back into a general complementary function, alpha is this term right here, and beta is this term right here. Well, really I should say this term right here, because this is used to plug back into these. So that's where you would use a different alpha and beta to not get confused, but I'm not confused, so I'm going to keep them the same. So alpha is negative 1/2 and beta is the square root of 47 over 2. So now, just like we did before, we write the complementary function x sub c is equal to e to the alpha t, which is e negative 1/2 t, times c1 cosine of beta t, which is the square root of 47 over 2t, plus c2 times the sine of beta t, the square root of 47 over 2t. That's it for the complementary function. Now, for the second part, I'll denote that part b is to find x sub p, the particular solution. X sub p can be found using either variation of parameters or using undetermined coefficients. I'm going to use undetermined coefficients because I don't want to have to find the Wronskian of anything, and I don't want to have to integrate anything until I have to. So I'm going to find x of p is equal to a sine of 3t plus b cosine of 3t. Now at this point we have to make sure that there are no repeating terms in the particular solution and the complementary function. So we can see that if we multiply e to the negative 1/2 t to the first term and e to the negative 1/2 t to the second term, both of those terms are not going to repeat with either of these terms here. Meaning we can keep x sub p just how it is. Now we find x sub p prime, which is going to be 3a cosine of 3t by the chain rule, and then we have minus 3b sine of 3t also by the chain rule. X double prime sub p, x sub p double prime is going to be negative 9a sine of 3t by the chain rule minus 9b cosine of 3t by the chain rule. And now we plug these back into the initial differential equation. So it's going to be x double prime of p. Oh, and I'm using this equation, by the way. So actually I'm not this one, because we plug every terms in after that. So I'm going to multiply through by 2 in this equation. So it's going to be x double prime of t, x prime of t 12x equals 20 cosine of 3t. So we'll keep that in mind. And then it's plus this x prime of t, x sub p prime, and then it's plus 12 x prime of p. So it's plus 12a sine of 3t plus 12b cosine of 3t, and this is equal to 20 cosine of 3t. Now we're going to have two equations here, because we have sine of 3t and we have cosine of 3t, and there's no other terms. So we'll just set like terms equal to like terms. I'm going to do this part, I'm going to do the grouping part in my head because I don't want to have to rewrite this whole thing and, I'll just waste time. So we'll count out which terms we have. We have a sine of 3t term here, a sine of 3t term here, and a sine of 3t term here, and no sine of 3t term in the right-hand side. So basically we're going to have minus 9a minus 3b plus 12a, which is 3a minus 3b equal to 0. Minus 3a minus 3b equal to 0, which therefore means a is equal to b. The second is going to be all of the cosine of 3t terms set equal to the right-hand side. So we have minus 9b plus 12b, which is 3b, plus 3a equals 20. So we know that a equals b, so if 3a plus 3b equals 20, that means that 6b equals 20, which therefore means that b is equal to 10 over 3, which means that a is also equal to 10 over 3. Now we can plug these a and b terms back into the particular solution. X of p equals 10 thirds sine of 3t plus 10 thirds cosine of 3t, and that's the particular solution. So now part C is to write out the entire solution. X of t is equal to x sub c plus x sub p, where x sub c is this term right here, plus this term right here. And that's by the superposition principle. This is a little bit big, so I'm going to shrink these two down. I love technology, although sometimes it can be a real hassle. So that is the general solution. Now we have to do part D, which is to solve for the initial conditions. The initial conditions are x of 0 equals 2. So we can plug everything in. And I'm going to need to find, before I do this actually, I'm going to find the derivative of x of t, because I'm going to need that for the second initial condition. X prime of t equals the derivative. This is going to be a product rule and a chain rule. We'll do the chain rule first. So the derivative of the first is going to be negative 1/2 e to the negative 1/2 t times, I'm going to need to write smaller than this, times c1 cosine root 47 over 2t plus c2 sine root 47 over 2t plus the derivative of the inside plus the first times the derivative of the inside, which is e to the negative 1/2 t times the derivative of the inside, which is going to be a chain rule. So the derivative of the inside is root 47 over 2, and then the derivative of the outside is negative sine. So negative 47 over 2, negative root 47 over 2t sine root 47 over 2t plus the chain rule again, which is root 47 over 2 c2 cosine of root 47 over 2t. And then we have the derivatives of these two here. So I'm going to write them, I guess, below. So the derivative of the inside is 3 times 10 over 3, which is 10, and then the derivative of the outside is cosine, so it's going to be 10 cosine of 3t. And then the second is going to be also the chain rule, but this time it's going to be negative because the derivative of cosine is negative sine, so it's negative 10 sine of 3t. Now we can do the initial conditions. And I know that I can probably combine some of these terms up here, and I probably should, so I'll go ahead and do it. X prime of t, there's going to be a e to the negative 1/2 t term that is going to be in all of these terms here. So I'm just going to bring that out front. E to the negative 1/2 t is with all of those. Now with C1 and I forgot to write C1 in this term here. I'll just write it up here. So with C1 and this term and this term here, then let's see what we're going to be able to take out. There's going to be a negative 1/2 with the first C1 right here. There's going to be a negative 1/2 with the second term right here. So let's take out a negative C1 over 2, and then this is going to be cosine of root 47 over 2t times, I'm sorry, not times, plus root 47 sine of root 47 over 2t plus, that's all the correct parentheses there. And now the C2 terms, we have a negative 1/2 C2 with this first term right here, and then we have a positive root 47 over 2 C2 term there. So let's just take out plus C2 over 2, and I'm going to do this one first. Root 47 cosine of root 47 over 2t minus sine of minus sine of root 47 over 2t. And then we have these two terms right here. So that's going to be plus 10 cosine 3t minus 10 sine of 3t, and that is the new form of x prime of t with all of the combined terms. So now let's do the initial conditions. We have x of 0 equals 2. So 2 equals, I'm working with this equation up here. So e to the negative 1/2 times 0 is 1. Cosine of 0 is 1. So we have C1 plus sine of 0 is 0, so we don't have to worry about this term here. And then sine of 0 is 0, so we don't have to worry about that term there. And cosine of 0 is 1. So C1 plus 10/3, which means C1 equals 2 minus 10 over 3, which is 6 over 3 minus 10 over 3, which is minus 4/3. Now we have x prime of 0 equals 0. So we'll work with this equation right here. 0 equals e to the negative 1/2 times 0 is 0, or it's 1 because it's e to the 0. Negative C1 over 2 is negative 4/3, which is positive 4/3 divided by 2, which is 2/3, times cosine of 0 is 1, plus cosine of 0 is 0. So it's 2/3 times 1, plus this side now, c2 over 2. It's going to be cosine of 0 is going to be 1 times the square root of 47. So we have the square root of 47 over 2 c2 minus sine of 0 is 0, plus 10 times cosine of 0 is 1, minus 10 times sine of 0 is 0. So let's rewrite this as the square root of 47 over 2 c2 equals 10 plus 2/3 is 30 over 3 plus 2/3 is 32 over 3, so it's minus 32 over 3, which means that c2 equals 2 times negative 32 is negative 64 over 3 times the square root of 47. And those are the C1 and C2 terms, which means part E, we can write out the entire general solution. X of t equals e to the negative 1/2 t times C1 negative 4/3 cosine of the square root of 47 over 2t, c2 minus 64 over 3 roots of 47 sine of the square root of 47 over 2t, and then we have plus 10/3 sine of 3t plus 10/3 cosine of 3t, and that is the final answer. You see, these do take a long time to solve, but realistically, there's simply everything that we've learned up until this point. So they're not that difficult if you know how to do everything else. The most difficult part is probably writing everything down and finding writing the general solution, as in this equation right here. Because once you write that equation, then you can start to work from your knowledge of finding the auxiliary equation, solving for the complementary function. Then once you do that, then you can solve for the particular solution using the methods that we've learned. And obviously you will have to know those. So this method, working these problems assumes that you know how to do everything else from the other problems. So if you're struggling with the previous sections, then you're definitely going to struggle with these sections too. So if you have a spare couple of hours, then go through and work some of the other problems from the other sections, because they're going to help you no matter how long it takes you to do them. Like, if you spend 30 minutes working on a problem and you find out how not to do it, then that's going to be a lot more learning experience than not doing it at all and then getting the problem wrong on the exam whenever you could have spent at least 30 minutes doing a problem and getting the answer correct. So if you watched this entire video, thank you for watching. I hope this helped. And real quick, I'm looking in the back of the book right now to see what the answer is. This is section 5.1. The question number is 33. And the answer is definitely e to the negative t over 2, I have that, times the quantity negative 4 over 3 cosine of root 47 over 2t minus 64 over 3 times root 47 sine of root 47 over 2t plus 10 over 3 times the quantity cosine of 3t plus sine of 3t. So that is the final and correct answer. So if you have any questions, please comment, send me a message, and I'll try and get back to you. Thank you very much for watching. Have a good day. Bye.